Hello everybody, welcome back to another RevWise video. Today we're going to be going through some GCSE/IGCSE chemistry topic-based questions, specifically calculation questions to do with chemical formulae, equations, and stoichiometry. So let's get right into these questions. We're going to do a couple today. So the apparatus in the diagram is used to heat a sample of hydrated copper 2 sulfate crystals. And we see here it gives us this. And if you don't know, this little dot 5H2O you see there, that just indicates that it's hydrated. So the equation for the reaction that takes place is this, and we can see it's becoming CuSO4 plus 5H2O, so they're separating, and this is usually in the presence of heat, so I'm sure it'll say something about that later. So draw an arrow on the diagram to show where heat is applied. Yeah, just as I guess it's gonna talk about the heat. So we know that the heat is causing this reaction to occur, so the heat has to happen where the hydrated copper 2 sulfate is, and therefore we have to draw an arrow somewhere around right here. Just arrow straight up. That's exactly where it's going to be applied directly to the tube where the hydrated copper 2 sulfate is, in order to heat it up so that the reaction occurs. Now B, what is the purpose of the ice? So we can see that over here we have ice in this tube, in this beaker, where the tube is in, and there's water. And usually in this, it's pretty easy to infer, but usually when you're cooling something, right, it's for condensation. Generally in apparatus like this, you have a gas that you want to become a liquid, something like that. It's easier to quantify it, to measure it as a liquid. So generally, if you have a cooling area or if you have ice, it's to condense a gas into a liquid. And that's exactly what's happening over here. The ice is used to essentially condense the steam/water vapor that's going to be coming in order to get some liquid H2O. So to condense gas, and we'll add a bracket, water vapor. There we go. Very easy. Now let's see. Calculate the maximum mass of water that could be collected when a sample of hydrated copper 2 sulfate of mass 2.5 grams is heated. Good question. So we have 3 marks here, and essentially 3 steps that we have to go through. Okay, so first step, we have to recognize that we need to get the number of moles of the hydrated copper 2 sulfate. Now how do we do that? Well, you should be able to instantly work out what we need, and I'll draw you a little equation triangle to help out. So if you have this mass mR moles, okay, N is moles, mR is molar mass, and M is mass, right? So this is essentially how it is. This is the equation, and this triangle helps you understand it, because if the mass is above the other two, so you divide mass over mR to get the moles. And just how you do that, you can use the triangle to see that you multiply these two together to get the mass. You divide mass over moles to get mR. So that's a nice little triangle you can use. And from that, we can recognize that we need to do mass over molar mass in order to get our moles. So what is our mass and molar mass? Well, we're trying to get the moles of CuSO4 hydrated, okay, and that is just going to be 2.5 grams being our mass over our molar mass, which it says right here being 250. So now that we've done that, we know it's going to be 0.01 moles. Okay, simple calculation. They usually make the numbers nice with each other, so you can calculate it pretty easily even in your head. So 0.01 moles is what we have. Now, this is the number of moles that we have in this entire compound, but we're looking for the maximum mass of water that can be collected. So now we need to get the moles of water. How do we get the moles of water? Well, we have to look closely here. See, in every 1 mole of this, we have 5 moles of H2O. You see this 5 here? That 5 H2O, that number in front of 5, that's essentially telling us there's 5 moles of H2O for every 1 mole of our hydrated copper 2 sulfate. So we know that we have 0.01 moles of copper 2 sulfate. So all we have to do is multiply our moles for that by 5 in order to get the moles for water. So our moles of water is 0.01 multiplied by 5 equals to 0.05 moles. And now that we have the number of moles, we can go refer back to our triangle and we can see that moles times molar mass is equal to mass. So we just have to multiply our moles 0.05 multiplied by the molar mass of water, which is 18, and we multiply those by each other and we get an answer that should be 0.9. That should be right. My math is correct. 0.9, and that is the total mass of our water, 0.9 grams. Very simple. We just need to recognize that we need to use this triangle. We need to use the fact that there's 5 moles of water for every 1 mole of our hydrated copper 2 sulfate, and we can get the answer pretty simply.